The muscles and bones of the body constitute an intricate mechanism which has to do with all the activities involving form and body movement in work, play, and the many other expressions of personality. The gross form of the body is determined largely by the skeleton, which is essentially a flexible framework. But the 206 bones which comprise the skeleton would be useless without the nearly 700 skeletal muscles, each a power unit harnessed to this framework. Muscle and bone work together. A muscle works by pulling. It never pushes. When one muscle contracts, another muscle, called the antagonist, relaxes. Many muscles are involved in every body movement. Muscle, it can be stimulated artificially. When the circuit is closed, the muscle contracts. Let us now examine in detail how a muscle works. The muscle shortens also when its motor nerve is stimulated with electricity. A muscle comprises thousands of elongated cells. In one cell, we see the end plate of a motor neuron. Groups of cells held together by connective tissue form a bundle. Arising in the spinal cord, a single motor neuron branches to innervate the cells of many bundles. Neuron and muscle cells work together. This is a motor unit. Resting as a team, working as a team, this unit coordinates with others. Here it alternates with another unit, its periods of activity and inactivity. Scattered motor units contracting slightly throughout the muscle in irregular rotation supply a moderate tension called tonus. The strength of contraction within a single motor unit varies with the number of impulses delivered per second by its motor nerve. Increasing the rate of impulses increases the contraction. With an amplifier and an oscilloscope, we can record the tiny action currents here picked up by electrodes inserted into the contracting muscle. At rest, virtually no motor units are fired. Merely gripping the dynamometer requires the firing of a few units. A weak contraction engages more motor units fired at a moderate rate. A strong contraction requires still more units at a rapid impulse rate. Body posture is maintained by muscle tone. Muscles and tendons by the force of gravity. Tendon, we momentarily overstretch the tendon and its muscles. The resulting knee jerk is an exaggerated tonus reflex. Leaning for a minute like this has stretched the tendons of the arm-raising muscles. The resulting stretch reflex continues to operate, thus involuntarily raising the arm. Embedded among muscle bundles lie muscle spindles which initiate this stretch reflex. Sensory nerves leave the spindle. When stretched, the spindle generates nerve impulses. The more stretch, the more impulses. These impulses travel to the spinal cord and there reflexively stimulate the motor neuron, causing muscle cells near the spindle to contract. This is the stretch reflex. Sometimes the head falls a considerable distance before a relaxed muscle is stretched sufficiently to stimulate its contained spindles. Thousands of spindles in scores of muscles are successively stretched as gravity draws us in one direction and then another, each time to be checked by the reflex shortening of some newly stretched muscle. Easy standing posture is automatic and involves the stretch reflex, assisted and modified by nerve impulses coming from the ears, eyes, feet, and the neck muscles. Often we confuse a stiff pose, as shown here, with posture. Pose is an assumed posture. It involves conscious effort and is tiring. The round back and forward-drawn shoulders of this outstanding player betray the excessive demands which his sport places on chest muscles. Sports develop muscles unevenly. By contrast, the even development of an all-round gymnast reflects the nearly equal use of many muscles. The smooth contours of the swimmer are due to uniform, moderate muscular development. When some muscles are too weak, handicapping postural defects such as flat feet may result. The neglected leg muscles can be strengthened by specially adapted exercises. When such weaknesses occur in the body wall, especially when accompanied by fatness, the abdominal muscles may sag. Trunk flexions with quarter turns strengthen all of the abdominal muscles. Compare the poor alignment in this affected walk with this easy, graceful rhythm. Good posture is an aesthetic expression which has social value. It is very difficult to correct overweight by exercising because muscles use fuels too economically. Wrestling 5.5 hours burns only 1 pound of body fat. Sawing wood 10.5 hours burns 1 pound. To reduce, one must take in fewer calories than the body needs. This forces the body to burn stored fat. A slice of dried beef reveals bundles of cells surrounded by connective tissue. Magnification discloses muscle cells of varying sizes. Muscle strength is proportional to the area of its cross-section, approximately 140 pounds per square inch. Smaller cells grow larger when a muscle is taxed to its maximum. There is no increase in the number of cells. Such growth is called hypertrophy. Extra weights strengthen leg muscles. Trained to this overload, they perform easily in contest. Similarly, a piece of lead secured by wax is used to overload temporarily the ears of dogs to develop the muscles. Hence, the ears stand up at the dog show. Heavy exercises in the gymnasium are overloads compared to our regular tasks. Thus strengthened, we do everyday work easily and without effort. A continuous blood supply is necessary for prolonged muscle action. Here, an armband shuts off the blood to the finger muscles. A record is made as the muscles fatigue in pulling the weight. Cutting the armband reestablishes circulation. The power to contract is immediately restored. Stroke volume and heart rate determine the total blood circulated per minute. A small, untrained heart must beat rapidly, even at rest, in order to deliver enough blood. Endurance work enlarges the heart and increases its output per beat. This increased stroke volume is the distinguishing characteristic of the trained heart. Therefore, its work is done with fewer beats, a great advantage in hard work. The heart pumps blood to the muscles, but only working muscles can force it back. Blood vessels lying between muscle cells are compressed when the muscle contracts. Here the contraction forces blood to the right, toward the heart. When next the muscle relaxes, fresh blood from the heart rushes in. This pumping is the peripheral heart action of skeletal muscles and equals in importance the heartbeat in maintaining circulation. Sometimes a yawn or a stretch improves the circulation enough to relieve that tired feeling. The swaying movements of standing pump blood back to the heart. Forced to stand motionless, the return of blood is so reduced that the heart may be unable to supply enough blood to the brain. This leads to dizziness or even fainting. Heavy work develops strength of muscle. Endurance work, such as this, develops heart and lungs. Properly selected, these exercises may also develop that grace and agility which give the owner a body disciplined, alert, able to meet every